what I'll be talking about will be some microservices that my team of this many people have been playing around with. And I say playing and creating. There's a real aspect of play with this work. And that's kind of why I like microservices as a tool for us to build something. I throw this in here. This is the safe harbor statement. This is so if I swear or say something that other people find, my employer finds wrong, they're not on the hook for it. That's all me. These are my words. But I wanted to tell you what the whole effort over the last couple of years for myself and my team have been. And the effort has been, I work in the IBM Runtime Technologies team, which writes a Java virtual machine. In fact, over the last couple of years, what we've done, or what that development team has done, is take apart the components that make up a virtual machine, offer up some of the components to any runtime. So on top of those components can be the Java language, but you could also, and we have also put Python, Ruby, Node.js, Swift on top of those components. So we test those components at a layer below the languages. So we have a set of tests that live there. We also have pulled ourselves out of a lot of really old infrastructure, a lot of old proprietary brittle test tools, a lot of process where we were bottlenecked horribly. Well, I can't proceed because this and this and this and this and this, to the point where you almost had to take a knee. You couldn't go further. You were frustrated. You didn't want to come to work, or, okay, I'm speaking for myself, because all of the stuff that had been built up over the last 10 to 15 years within our group that I didn't help create, but I was now finding myself owning, was really handcuffing us. We couldn't move quickly, we couldn't move forward. We really have hundreds of thousands of tests and test material that we run. That's just in our Sanity suite. So for every pull request that a developer creates, it fires off hundreds of thousands of tests across more than 18 platform variants. So we don't just have a simple story of running on a Linux x86 64-bit machine. We have ZOS, AIX, all the different flavors of Linux, Windows. We now have a lot of things running in Docker containers, a Docker-based JVMs that we offer up. So we have to be able to run our tests in all of those places. And we wanted to be able to also make it really easy for the developers who are about to start contributing to all of these projects that have been open sourced in the last, say, 2 years, because OMR happened first. In the last month, we've open sourced our Java virtual machine. And since February, I've been helping at the AdoptOpenJDK project as well. So those are open source projects where you can go and find a full Java stack. If you use Java and you want to play around or you want to contribute either to the actual product code or to our tests, they live in the open now. So we had to make our testing first-class citizens as part of that. And so that should inform you of then how are we ending up playing around with microservices, and first of all, what is a microservice? So microservice really, I think of it as a succinct API, very specific, bounded set of functions that do a particular thing. So, and as I say, happiness knows no bounds, but these microservices do, and it's a good thing. You can put a whole set of microservices together and make it feel like a whole system. So in the past, where we've been handcuffed to a big, giant, monolithic application that lets us do all the things related to tests that we need to do, maybe. But if one part of that system failed, the whole thing is brought down, everything's shut down, we wait, we don't proceed. If you want to upgrade some part of that system, the whole thing comes down. hours pass. We can't afford to have hours pass when we're doing what we do. So by breaking up those monolithic test applications or tools that we're using into microservices, we can quickly move forward, quickly upgrade things, and really end up going a lot faster. It's remarkable how much more quickly we can move now that we've done some of this. This is a work in progress. This will still continue to happen and evolve over the next year or two, I have no doubt. But this is giving you a peek at what we've been doing. So you can use them in concert together, microservices, or independently as a single service. And a lot of times we use some of these that I'll show you, we just use as a one-time run, as an informed thing. There's probably opportunities to bring independent services together with other services. And one of the magical pieces of this is that I can have services talk to each other and share information as long as that API between them is well defined and I understand what exact pieces of data I want or need. So we haven't done all of that refining yet. We're still at the stage of, this is a task we want to do. This is how we're going to do it. Of course, some of the benefits are the modular thing, the portable thing, being able to write customizable applications by piecing together just the services you want. It's super, super easy to develop these. Once we've started writing a few of them, the first ones took maybe a couple weeks to build. Now we're down to, I can build a service in a day or a few hours, at least the prototype of the service. We can figure out if it's a useful service for us, and it didn't cost us anything if we throw it out. It's not like, oh, we spent 6 months developing something and now we find it's not useful. So it's a very freeing way to develop some tools for ourselves. But I wanted to say, vaguely what it looks like here are, in that middle layer, you have our services, or some of the services I'm going to talk to you about today. They draw from a bunch of different data sources, and here in this picture I've split it out as raw data and refined data, and I'll talk a little bit more about that. And then up along that top layer, I'm saying this is how we interact with these services. In many cases today, I'm going to show you a pretty, GUI, a nice looking dashboard, but there are some services in that list that have they're headless. They don't have a pretty GUI. They're very functional to us, but there's no reason to lay something pretty over top and make that information available through a nice looking dashboard. However, so what I'm going to say is, how do we think about what services do we need, or how did we come about the services we had? We started thinking about what are the activities that we were doing around test. So when I think about the activities that I'm involved in with the testing of a virtual machine, or a Java virtual machine, or any of the runtimes that we test, I think about, well, we have to figure out what we're going to test, the planning phase. We have to implement the tests, and so we have to think about how, and you could say this involves choosing what test frameworks you're using, that sort of thing. The automation phase, which I know we're in this track, and probably that's the one piece everyone wants to know about. It's not the only piece. There's a lot of other pieces, but that, to me, I'm asking questions like, how often do I need to run tests? How easy is it to add my tests to an automation system? And that was a really big focus for us in the last year. We wanted to make it dead easy for developers to be able to add and edit tests, because we're really only 5 or 6 people with a team of hundreds of developers. We're not going to be writing the tests for them. They have to be involved actively in writing tests. Mentioned after some of the talks in this track that there is this convergence, there is this kind of blurring of the lines between testing and development. My team, I like to think of them as a special elite forces team. We find places where we can offer help. and we strategically strike. What thing can we do now that will help and benefit the most people, unlock them, empower them, so that we can test better? And I won't say test more, because that's not really my goal in the execution of the tests. Some of the questions I ask are, how few can I run? And how fast can I run them? And that relates also to cost, for sure. But for us, time is a real cost, because if I have a team of a few hundred developers sitting, waiting because a Sanity suite takes 2 hours to run, no, that's not acceptable. We want to run those 100,000 tests in 15 minutes or less, and we want to be able to break up those tests across multiple machines and run them in parallel and orchestrate them in certain ways. Over onto, you can combine the triage and exclude and execute all in one big square, but I did break them out. So when I do run these tests and one fails, how quickly can it be triaged? How quickly can I get to the core of the problem and figure it out? And I'm not the one triaging all the time. How quickly can a developer do that? How easily can they rerun the problem? And I think if any one of you were at the Docker for Testers tutorial, one of the reasons we have a lot of Docker-based testing that we're trying to roll out at some of the open source projects now is that that container can be the thing I hand over to someone and say, the failure is there. You can see it, you can run it, and you can see the failure that just happened. So it's a way to snapshot and have an artifact of the failure, at least for a brief time. Anyone who's kept a Docker image laying around for a while knows you're not keeping those forever because they take up a lot of space. And then the exclude. If I need to exclude a test while a fix is being worked, it better be darn easy to exclude it. And I better have a common way to exclude that test. So if I'm running performance tests and I'm running functional tests and I'm running load tests, I'd like to be able to exclude them all in the same way. I shouldn't have to write documentation for 5 different ways of excluding tests because there are 5 different types of tests and that sort of thing. So we've kind of come up with a little way to do that. We're still obviously improving that story, but by making those common, and even the reporting, making that common where I can always know where I go and how to read the report, even though the formats of all these different frameworks and benchmarks are completely different, you reduce the time it takes you to get to the source of problems, you increase the productivity of the whole development team, you make your life as a tester or a person who's trying to help productivity a much easier life to live because there's less documentation, there's less maintenance, and people start to get it. They start to be able to predict how to find things. They don't need you as much, and so that frees you up to do more interesting things. All right, so I'm going to quickly dive into each one of these phases, talk about the planning phase and what tests you need. That goes to what information do I have available to me at my disposal? What data do I have to be able to gather up information to decide what additional testing I might want to add? So one of those questions are, how do people use our product and what are their user stories? For us, one of those places, one of those sources of information are the core file. So if you test or have used Java and the thing crashes, it creates a big core dump file that we can look into and know a lot about the execution environment that happened and know a lot about what command line options you were using. Now for you, if you're not testing a Java virtual machine, there's probably still a configuration file somewhere that you know a little bit more about what your customers or the customers of the application you're testing, how they're using it. You can look for that information. Other additional information we have, now that all our source code is in a GitHub repo, so all the product source is open sourced out into these open source programs, we can look at one, we can run code coverage, obviously we have that information, but we can look at how those files change in that source code repository. And we can actually look at the churn in certain files. And it turns out that that information is really useful for us. And you probably some of you have already read some of that research. There are very sophisticated tools that will let you figure out, you know, where are the hotspots in the file, or how to predict where bugs will live in your code. But a really inexpensive way of predicting this is actually looking at how often a file changed because of other defects. So where bugs live, if you keep having to change the same places in your product code all the time, over the past 5 years, 20 bugs lived in this one file, the chances of it having more bugs is a lot higher, and it's a very good tool for predicting where the bugs live. So we wrote a service that lets us keep an eye on that in our source code repos, so that we can say, oh, the top 10, and we can track them, and we can say, we can decide, do we need to bump up testing in those? And then the core analytics file, for us right now, we're looking at these service reports, these customer problem reports, and we're able, in particular, we wanted to see what command line options people were using, because we might want to run with those input parameters a full test suite using the most commonly used inputs. So I'm going to go through this, and then at the very end I'm going to try to show you some of these services, just a quick view of them. I won't break in the middle here because it might take too long. Moving on to the implementation phase. So this is, you know, how do I best design and write my tests? What tools do I use? Frameworks do I choose? How do I minimize the number of tests while maximizing functional coverage? So not line code coverage, but actually, you know, do I use the correct inputs here? And this relates to our earlier core analytics service, because I'm gathering information about the inputs I want. But it also relates to, you know, maybe we apply some combinatorial test design. And in fact, we did this. We have a prototype of this. We've used it for the OMR project, actually, to design some of the JIT tests that we wrote for the very low-level functions, the opcode tests that we have there. So, you know, 500 plus different opcodes on an operating system, but we can model those tests, or model the tests and inputs that we want to use for that to reduce the number of tests we need. And in fact, why should we do that manually? Why should we have to write these out manually when we could really just point at a header file, look at the input parameters, and offer up the input test array that someone should, if they're writing a test for this, use. And that will also enforce that our tests have a common look and feel, they're easier to read, common formatting. So we've prototyped that now. We want to go to another, you know, work in progress thing where we actually can just point to the GitHub repo file and say, hey, generate some tests for me. And this is probably going to be popular with our development team because they hate writing tests. Some of them don't like writing tests anyway, and this will help them a lot, at least get the framework in place and the inputs in place. Automation phase, so how do I really add now my new tests to continuous integration workflow? How do I replace our old practices with new ones? These are the questions I'm asking at this automation phase. And in this, the example service that I'm going to just briefly mention in this phase is actually our, we'll call it a bench engine service. So we've run a lot of performance benchmarks against the JVM. And we have a team, in fact, that does this. And that team had been suffering under this, using a very, very old, clunky, painful, stitched together tools to launch benchmarks and be able to kind of track the results. We have to be able to launch benchmarks on all of those different platforms, which means in the past, platform-specific scripts that were manually edited and you know, tweaked as you went. The bench engine service essentially just generates the script on the fly for you to run based on an easy-to-write benchmark definition file. So anyone can easily maintain that file for the different benchmarks that we have and then feed it into the service. It'll generate the script for you if you just want to run it standalone, but it'll also just, a click of a button, submit the job to Jenkins and run the benchmark on the machine of your choice. It has to be matched up with the platform for the script that it generated, but it does that and takes care of that for us. What this allowed us to do is stop having a queue of developers ask that performance analysis team, can you run a benchmark for me? I need you to run a benchmark for me. They were being stopped with their own work because there was this lineup of developers that said, I don't know how to run benchmarks. I don't know anything about it. Now they can very easily launch their own benchmarks, run them, understand what are the things that you actually care about looking at once you run them. And so we're finding that this has really freed up the development team, or will free them up even more once we get all the benchmarks running on this in this new way. But the other thing that happened was that performance analysis team. So we wrote this service, a student of mine wrote it, and it took us a while because we didn't know anything about the benchmarks that were being run. We had to kind of take a look at this old piece of tooling that was being used for that earlier. So it took us a couple of months to get this thing written. And now the performance analysis team, we've handed it over to them. So they now add features to Bench Engine, and they're adding benchmarks. And it's easy for them to do so. So now we have new contributors to that service. And I think it's annoyed the lead of that team because she said, my people are having so much fun coding this that they're staying up till 4 a.m. and now I'm wondering where they are at 9 when I wanted to talk to them. No, I don't think she's really saying that. But the point is they are having a lot of fun, and we successfully handed it over to a team that was afraid to touch the other tool. All right, execution phase. So this goes with what is the minimal set of tests that I can run for a given change. So we have gone through the exercise of how do we do change-based testing rather than run the entire suite of hundreds of thousands of sanity tests that are marked as our pull request set that gets run. Can we be smarter than that? Can we look at the change and actually say, really, we only need to run this set. And that means we have to tie it with some code coverage information so we know that we're confident in the set of tests that run. And then again, what input options do I run with? And what's the execution time? Can I track it? Did it change radically? Because that actually would be considered a bug as well. The test may have passed, but now instead of taking 300 microseconds, it's now 4 minutes. What? So those things should be flagged. So we have a couple of services in there. One is that test selection service. So it is going and looking at code coverage information and generating the smaller, smarter set of tests to run on a pull request. And then I did want to talk a bit about this input options service because this is one of the examples of a headless service and what it's really doing. And if you look in the background, if I connect to that service with my browser, that thing in the background is what I actually get back from it. What? So we never connect to it with a web browser. Our automation tooling connects to it and says, okay, some developer added this test, and they've added this set of command line options to run. So we have this thing where you can have a test and then parameterize the options that you pass in. And they have 4 different option sentences or variants that they want to run with. But number 3 in the list actually isn't applicable on this particular platform that we're running. It makes no sense to run it. So all that input option service does is verify the validity of these input options. But what we can also do with that service is tie it to that customer kind of the core analytics service and say, well, you know what, in this particular test or this particular set of tests, we probably should be running with this set of options because we see that a lot of these service, these core files that came into our service group have been running and clearly failing, crashing with these set of options. Maybe we better boost the testing in that area. Over to the triage phase quickly. These ones are more work in progress. We are doing these services as a background to our main roles as making sure the JVMs are good quality. So you can go to AdoptOpenJDK and download a pre-built one and you can be assured that a bunch of testing was run against it. But for this triage phase, one of the services we're working on that we're kind of interested in, we're going to try to answer the question, has this happened before? So we're connecting into that refined data in the bottom where we are gathering test information from our builds in Jenkins and storing some of it historically so that we can go and say, this happened 4 months ago. Did it happen on the same platform? It did. No, it did or didn't. We can know these things, but we could say, no, it's never happened except on this particular machine. Or, we can start to make connections so that we can auto-triage some of the problems that we might come across. The other information that you might want here, I'm tying in the excludes here. Do I need to exclude this test? And then once there is a fix in, can it be auto re-included so that no one actually has to get in there and be able to do it? So again, I won't talk too much about it, but essentially that results analytics service is, can I automate the Googling of error messages? Has this happened before? Where did it happen before? Did it happen on this Jenkins server in this open source project or another one internally? We manage several different build infrastructures now. So I want these services to be able to connect to all of my Jenkins servers for data, for that raw data. If I were just at one server, maybe I could get away with just writing a Jenkins plugin. But again, I get into that problem of I've tied myself to Jenkins. And over the past 5 years, I've seen us change tooling as a corporate decision many times. And I don't like to be coupled tightly to things because it costs me time later. So whatever interactions we have with tools, we try to keep at a minimum. And finally, the reporting phase. So can I summarize this large, diverse set of tests? Where can I see that test report? Can I compare the results quickly, easily, and from all these different data sources? But most importantly about the reporting phase is when I look at the report, if it's a read-only thing where I don't have any actions, I can't take any actions, it's really not as valuable to me. So when I say, I look at that stage in my testing, the question I want to do is, what do I do next? Like, now I have this information, what happens next? And can I do it from the tool that I have or the service that I wrote? So here we have the results summary service, which gives us a summarized view. It's kind of a colorful thing that'll tell me green or red, maybe. But I also have that comparison service. And in particular, it's quite interesting for us from the point of view of benchmarking, because we want to be able to see if a performance regression happened. Where did it happen? Or has there been a drift over time? So we've got this summary service that connects in. I'm not going to spend too long talking about it because I do want to show a few things live. And then the results comparison service, depending on what results you're comparing, if it's the performance benchmarks, I can then have this overlay, this very pretty GUI on top to show me a chart-based view of it and to let me scan in really closely and in fact interact with that graph to say, ooh, what was that big spike there on January 8th? Click on that, it'll take me to the build where that happened and show me the changes that went in at that time. but it could be important for me to be able to also compare those across the different platforms, because say it only happened on one platform, that will help me hone into the change as well. All right, so that was the big scanning overview of all the microservices that I was going to talk to you about today. They're not all the ones we have or all the ones we're imagining that we could have, but there are some of them across the board in all the different activities of test. And so I would like to just, at the very end of this, I'll show you briefly some of those just so you can get a sense of what can be written in a very short space of time, 2 weeks or less, from a team of elite special forces testers, because, you know, essentially what we find ourselves in is this world of being agile, this world of crossing and not having those boundaries anymore of I only do this one thing. So when Noam asked me what is my title, I actually choose not to have a title for the most part, because I don't want to be restricted by, oh, she's the test lead, or oh, she does this one thing. I don't want to be blocked in by that at all. So my title is Conjurer for this conference, because we're talking about the magic of testing. But I really rather not have a title, because I do want to be able to play and strike strategically at problems when I see them. So we have just a little bit of time. Okay, so I'm going to jump in quickly, and I do want to say I'm going to be over at that huddle area if you have questions after this as well. There are, of course, gotchas when you host these things in the cloud, like do I have network connectivity? And in our cases for some of these services we do have the fallback plan. I do want to mention some of the open source projects that I'm at, and that all of the stuff that we did as a base for these services live there. We want to bring these services to the open as well so other people can use them. But maybe I can just quickly pop out of here and show, just so you have a sense of some of these services. This is that one showing code churn, right? So if I want to see something in my top 20, and I want to just go look at this file, what I'm going to get to see is it was already listed here in number 9 of most changed file, most changed because of defects. And I can then go and see what were the changes and click on them and see the change set and understand the differences. And that's important to me when I want to design tests. If I want to look at some of the core analytics stuff, another really pretty GUI, right? I get to see what percentage of our customers are running on what platforms, all the different platforms we test on and support. But then I want to see, here are the options. So I look here and I go, oh, I'm actually very interested in maybe some of this shared classes, which is IBM-specific option for optimizing the use of the JVM. And I want to click on that and see, oh, they set this in their command line, and these are the values they set, and this is how many customers set this particular value. So the ones with the higher numbers probably mean I should probably be adding those into my test system. And then quickly just, I do want to show one of the performance dashboards. So this is actually an interesting dashboard. This is that test comparison service, where in this case we're gathering performance below the language layer. So how do we do that? We actually look at the GC verbose logs. We gather them over time. And I can look at the mark time or the sweep time in those verbose logs and track it over a date range. And once I do see that, I can see them for different things, the average, the min, the max, and I can click on and get a closer look at that. For our Linux, PPC 64-bit compressed pointers spec, and I can then compare that against this other spec, and I can click on these spikes, and it'll take me to those builds and what changes happened there. So it's kind of a work in progress, I will say. We're coming up with, more interactive views of some of these benchmarks so that we can actually zoom in and take a closer look. We're having a lot of fun playing with this, and I guess I should say, Some of these things are to make developers' jobs easier so they can be testing. And some of that is also related to making our job easier so they can be testing. But that's about all I had today. If people have questions right now, maybe we can field some now, but I will also say come talk to me after if you want to do a yoga stretch or something.